Hello. I hope everyone can come back. People might have commitments, but I guess they'll have to watch the video stream after the fact. So I wanted to start with some questions sent to me by Jian. And it's gonna wait till we begin at 5:45. Who's here? It's just a few of you. I think only 2 or 3. Even though it says 5, I have 2 computers on, so I count for 2. So what I'm gonna do is start with hi Chloe. I'm going to start with the questions for the exam from last year. It was October 28th and November 2nd. These are, I think it's the last one in the list of exams. Yes. So I'm going to look at these 2 problems and then I will see if anyone has anything particular. Otherwise, I will go back to the exam we were working on yesterday. That was October 26th. So he asked me to look at problem 16 of that midterm and then 3. So I'm going to pull those up. So problem 16 is this one. Okay, so this is a part of this one here. So if you want to read this, Leonardo da Vinci believed that a person's height could be predicted from his arm span. The distance measured across the back between the person's fingertips when the arms are held straight and horizontal. The values for both variables are measured in centimeters for a sample of 8 individuals. The scatter plot is shown below with the least squares regression line. So you guys can see that graph, and here you're given the information, the least squares regression line derived here. Also, you get information on the mean and standard deviation. And jumping to question 16, it asks, what is the correlation? What is the value of the correlation between the 2 variables? So from this information, how do I find correlation? I'll just show that question. Oh, I can't move it up. Anyway, that's the question 16 below. Oh, there, I can move it up. Okay, so what is the value of the correlation between arm span and height for this sample of individuals? How would I find that? So no ideas from you. So what you should be aware of is the relationship between the information given here and R. Okay, work with what you've got. Work with what you've been given. Sorry, this is a little crooked, no? So working with what I've been given, I know that, make this big, that B is equal to RSY over SX. Do you see how you can use that? If you know B and you know sy, and you know sx, can't you find r? So that's what you've been given, so you can solve for it. Exactly. You see that? So I'm going to leave that to you because it's going to be messy on here, but that's how you would solve for r. You need to remember that, okay? So you can use the expression to find the slope. The slope and the r have the same sign, and they are related by this expression, okay? And so if you have all that information, like I said, you have this b, you have sy, and you have sx, so you can find r. Just looking at this, how do we know that b and r have the same sign? I know because both sy and sx have to be positive numbers, all right? They have to be positive because the standard deviation, the sample standard deviation, is the square root of a number. The square root of a number will always leave you with a positive. So these are two positives multiplied by r. The only way for the slope to be negative is if r was negative. Anyway, that's aside from the point. Okay, so you can just calculate that to find r. So that's the answer to that question. That was question, no, I don't remember, 16? I'll call it Q1. And now let's look for, he also asked me to look at problem 3. So I'll go back to the exam and look for problem 3. Aha, oh, fun. So, which of the following histograms displays the set Chloe, you're asking me about the answer to that one? Okay, you guys can try it. I'm not going to do it. Just plug it in and check the solutions at the end of the exam to confirm that. He just wanted to ask, John just wanted to know how to get the answer. So if you plug that in, you can find it. Okay, so now, which of the following histograms displays the data set with the lowest standard deviation? What an interesting question. So which one has the lowest standard deviation? I'll let you think about that for a bit. Oh my goodness, you couldn't hear anything? Sorry, Chloe. I have to go back and do that again. Oh my gosh. All right. Remember to use my timestamps when you review these videos. That will help avoid wasting time. Okay, so let's do this again. What was I saying about question 3? Question 3. So here, A is the answer because standard deviation is a measure of the square root, right, of the average of the squared deviations from the mean. So it's a measure of how spread out the values are from the mean. So the smaller standard deviation would be that one where a lot of the values are close to the mean. And this is the option of all of them where most of the values near the mean bunch up around the mean. Okay? And there's just a few far from the mean. That's not the case with the other alternatives. Okay, it's only the case here. So that's why A is the right answer. Also, in your discussion about 16, John, 0.915 is the right answer. It's option D for question 16. Okay, sorry, Heike. Yeah, I know some of you will have class today, so I apologize, but yes, you can watch the videos and use the timestamps so you don't waste time. They'll help you click to solving problems that interest you. Bye. Okay, so let's see. No questions about that? And so I'm going to go back to problem from what we were working on yesterday. I asked you to try all of these problems and see which ones bothered you. Let me know. No, pick some and let me know if there's any in particular you want me to do. I guess I'll pluck one out of each of the units. Okay, so let's look at this question 4. Four and 5 go together, so let's look at them together. An example of a flight departure board at an international airport is shown below. The variables flight number, departure time, and departure gate are what kind of variable? Give you a minute to try that. Okay, so flight number have letters and numbers in them, right? This variable here. So, and the numbers don't imply or signify anything in particular, otherwise just simply distinguishing one flight from the other for Air Canada and QF and LH. I'm not sure what airlines those are. And so these are categorical, and because the order doesn't matter, it will be nominal. So we're down to options A or C or E. We're pretty sure about that. Okay, next, departure. Departure time. Departure time. So several flights could depart around the same time. And time is in order, right? We know 8:30 comes before 8:35, comes before 8:45. So this is actually going to be considered categorical and ordinal. All right, it's not quantitative because you guys can ask me, do you think it's quantitative? Does that bother you? Or does this option confuse you? If it doesn't confuse you, I'm going to leave it at that. So this is categorical, and it's in order because the numbers tell you something. Relatively speaking, the numbers will tell you if one's before the other. One time is before the other. Okay, and the last variable that we're going to look at is the gate. The gates, oh, sorry, so we can cross out, E, and we're down to A or C. That's not right. So it's either A or C. So the question is, are the gate numbers for different airlines, notice that, okay? Gate numbers, are they in some special order relative to each other? Well, so that's going to make the difference. If these were all the same airline, gate numbers would mean something because usually the gate numbers tell you, when you walk through a terminal, it'll say gate number 7 and then 8 and then 9, like they go up in order. But that's not the case here. These gate numbers are categorical in that it's not meaningful to average these numbers in any way. Because different airlines might have different number of gates, so averaging doesn't really make sense. Here, if they were all the same airline, then that would be meaningful as an order. But since they're not, these gate numbers are simply categorical nominal. So the answer to this is A. So thank you for trying, Chloe. We were close. Okay, but I'm picking A. Any questions about that? Would you like to try the next one? Let's see, let's try the next one. I'm going to move it up. We take a random sample of 40 flights departing from the airport and record the number of passengers on each flight, as well as the duration of the flight in minutes. Which of the following statements is true? Let me give you a moment for that, okay? Okay, it looks like I have to go back. Chloe was telling me the answer as recorded is C and not A. I could see people picking C as well, but I can also see A. You see, this is why I'm always privy to listening to students' complaints about this. So I would allow A and C as options here, even though I just explained it for A. I just find it confusing. What are you trying to do if they're ordinal and across different airlines? I don't know. So I would say I would be willing to accept A or C in this case. Going back to 4. Sorry about that. If that's confusing, let me know. So let's go back to 5. We take a random sample of 40 flights departing from the airport and record the number of passengers on each flight, as well as the duration of flight in minutes. Which of the following statements is or are true? The duration of flight in minutes. Duration. The duration of flights. Chloe, I don't think it's delayed. I just think I ignored your comments. Oh, I just didn't look. I was looking elsewhere. So I'm trying to solve these problems and read the chat at the same time. Sorry. Okay, so we could use a time plot to display the flight durations. A time plot. So flight duration, and this is the time plot would be if we looked at flights in order or something like that, or the departure times, that would make sense. But for duration is a variable. Well, duration is a variable that is just quantitative. And we could make we can represent the data or as a histogram or as a stem plot comfortably. That's true. A histogram would provide more information than a frequency distribution about duration of flights. A histogram, remember a histogram and a frequency distribution, very similar things. I'm not going to choose that one. So those are not exactly, those will give you the same information. Remember, we even talked about a histogram and a relative frequency histogram giving the same information in terms of the 5 features. So John is saying that he thinks the first one is true, but what would be your time? What would be your time variable? Order of what? So, you really want to make a histogram of the duration. It's just confusing you using the word duration where you think of that as time, and time plot you think of that as time. So it's throwing you off in that option. So I think the best answer is B. Is that correct? Okay, so that looks right. Questions about that? So this is just meant to confuse you, because if you try and do durations with a time plot, what exactly are you plotting? You have to introduce another variable to make a time plot, and that's not what I want to do. I just want to analyze a single variable, duration. All right, let's do another problem. So that was the GDS unit. Okay, here you have problems 6 and 7 related to these box plots. Yeah, Jan, they mean to confuse you with that question. So they give you the 5-number summaries. So you don't, well, you can use a ruler, I guess, to see what the values are, but it gives you the values, so you don't have to guess so much about extending these to the line, to the axis here. So the question is, the distribution of scores for professionals is what? So professionals is this one here. And if you watch my videos on box plots, you know how to look for skewness. Let's make this a bigger. So what we do is we look inside the center of the data. Remember, this is the box, the 50% of observations are in here. And this is larger on this side, the larger values. And then in the whiskers on the outside, this on the right, if you look at that as a number line, is larger than this on the left. So that's also right skewed, okay? So these are both indicating that the distribution is right skewed. So when it's right skewed, remember what that means. Right skewed, oh, this is symmetric, what am I doing? So right skewed means that most of the observations are together and there's just a few that are high, okay? So that would be right skewed. And in that case, the mean is pulled away from the mound of data. You know, most of the data is here and the mean is pulled away, but the median is a compromise between the mode which marks the class with the most observations, if you divide up the data with equivalent size intervals, okay? And the median would be in the middle of those two. So this is repeating concepts that we've discussed before. The median is between those. So that's always going to be the case, right? Because in calculating the mean, all the values are used, but in calculating the median, only the center values are used. So the median is not affected by those high or extreme values. So the answer here is skewed to the right, and so the median to the mean skewed to the right So it's B, right? B is the right answer. Skew to the right, and so the mean is likely greater than the median. So the answer is B. Okay, so now, number 7. If we combine the scores of all 29 golfers, then the overall median is equal to what? Interesting. How would you figure that out? Give you a moment. Again, I forgot to turn the audio on. Oh my God, this is so bad. Okay, so this is so it's like I'm leading you in the right direction. So basically, what I've drawn up here is my answer. Let me repeat. So what we're going to do for this question, let me erase that. So for this problem, combining all 29 golfers, so you have 29 as your end now. With 29, the median should be at 30, n plus 1 divided by 2. What is this line here? Let me do that again, because there's a weird line here. Oh my goodness. All right, so let me do that again. So the median is at n plus 1 divided by 2. N is 29, plus 1 is 30, so 30 divided by 2 is 15. The 15th observation. You need the 15th observation. So when you go up, to remember what you have here, 14 observations are amateurs, and 15 observations are professionals. And I want the 15th in order. Notice the professionals are ahead, are smaller values. So in order, you start here, and then you go to this group here. So in order, if I was to put all these values in order, the 15th observation would be right here, the maximum. The maximum of the professionals happens to be, it's not so visible here, but it is visible in the 5-number summary. So that's why the answer is 76, option A. Okay. A little bit tricky, right? But you guys, this is after you've tried the homework exercises, after you've watched all my videos, the ones that are linked in the Moodle page. These are challenging questions, all right? I agree, but they're exercise, they're practice to make you test your limits or to go beyond what you've seen before. So that's that. Let's try another one. Are there any ones in this test that you'd like? Any questions in particular, or you want me just to keep going? Remember, for the test on Thursday, you're going to get to choose from 40 problems. You only have to answer 30. Just like these. Okay, let's do, so that was GDS. There's just more problems here. No comments from anyone? Let's do some of these regression problems. So which of the following statements, so I have some examples like this in the notes. Which of the following statements can you guys still see? Yeah, these are tricky, right, Maylene? You guys still see me? I don't know why. This looks funny. Okay, yeah, you guys can see me. Okay, so let's do 11. I know, Maylene, they're very tricky, but I gotta leave you some. But you can ask me tomorrow, the ones that you still don't get, all right? I'll check back about this quiz, this midterm tomorrow again, and then we'll go into another one. I'll send you, well, let's try the last one that we just, so the final one. So I'll do this, I'll do some more on this one. And then some more on the last one that's listed among the midterm that I posted. So, okay, which of the following statements contains an obvious error? So I'm going to go through each of them one at a time. The standard deviation of ages for 5 friends was calculated to be S equal 0. Does that make sense? So when would S be 0? When would the standard error be 0? It would be 0, or standard deviation would be 0 when when there's no variation. All of the ages are the same. Now that would make sense if the friends went through school together and they were all the same age. So it's possible. It's possibly true. So this one is true. And for B, a variable x follows a normal distribution with a mean mu equals -5 and standard deviation sigma equals 7. Does that make sense? Are there any contentious issues about that one? Variable x is normal with a mean of -5 and standard deviation sigma equals 7. Any issues with that problem? I don't think so. So we'll say that's also true. Or it's fine, or no error. C, the females in a sample were shorter than the males, and the correlation between height and gender was calculated to be R equals -0.56. What is the issue there? Is there an issue? Remember what correlation is. Correlation is a measure of the direction and strength of a linear relationship between two quantitative variables. Which of those terms or which parts of that statement am I violating with this? In fact, I am violating one of those. The fact is that gender is not quantitative, it's categorical. So that's why this one is false, or this is an error, okay? So C is the error. Let's go through the last two just so you see the answer clearly. Even though a simple random sample was selected, 2/3 of individuals in this sample were female. Yes, that's possible, right? It's possible that when you get a simple random sample, you need to consider all possible samples, and among all those possible samples, one could be where, even though it was random, where you labeled everybody first and then selected from the labels in a random fashion, it could possibly be that the ones you select, most of them are female. Why not? E, the experiment was double-blind, and so even the doctor had no idea whether patient was receiving the actual medication or placebo. Yes, that's the idea of a double-blind study. This is true and this is true. These are all true statements. So the answer here is C. Okay, let's do number 12, unless you have any questions. Okay, determine whether the correlation for each of the following pairs of variables is most likely positive or negative. Should I give you a moment? Give you a moment. I'm turning my mic off. Okay, I'm back. So, determine whether the correlation for each of the following pairs of variables is most likely positive or negative. Okay, the first pair, speed of wind in a snowstorm and visibility. So the more the wind blows, the stronger, I don't know what to call it, stronger or faster the wind is blowing, the more blurry the visibility. So these would be positively correlated. Okay, so from that, I can keep B and D. Oh, that narrows it down quite a bit. Actually, wait, visibility, no, those are negatively correlated. What am I saying? Those are negative because visibility is 0, means you can't see, right? So the faster the speed, sorry about that, the faster the speed, the less visibility. So that's negative, I don't know. So this is here, A is good, C is good, and E is good. So that narrows it down to 3. Next, the global supply of oil and the price of gasoline. Very good. What would that relationship be? The global supply of oil and the price of gasoline. Well, we understand that when there's a lot supplied, then there's more competition, right? And the price goes down. This is negative as well. Okay, so I guess you need to know a little bit about economics for that. So when there's less, the price gets pushed up. So that's also negative. So we're down to, I can erase this one and be down to C or E. Finally, the number of people in line at the bank when you arrive and the time until you are served. So the more people at the bank when you arrive, the longer you have to wait to be served. So these are both going to be positives. So that makes the answer C. Is that right? Is everybody okay with that? C? So think about it. So in the test, when you're writing, I told you could submit your handwriting or your written work, and so in there you can write your assumptions or how you're thinking about the problem in case you're you're baffled by choosing between two options. You're torn, and then you have to choose one. So you choose one, but then you can explain why, and if it's a good defense that you make for your selection, I'll consider it and give you some part marks. Okay. So that's the way I resolve if there's a misinterpretation of problems because of language or just because of lack of, a poor interpretation of a badly worded question. In particular, if you want to ask me anything during the test, I will be available. You can text me questions, okay? You have my number, I believe. You all have that, or you can ask me anyway. I'll be online. You can ask me in the forum if it's a general question. I'm not going to ask you any. I'm not going to tell you. I'm not going to teach you anything. I'm just going to answer general questions that are confusing. You can put them in the forum, or you can text me. Okay, so let's see. Should we do 13? This one's easy in that we did discuss this before, and it's driving home the point about the correlation I'll just write it in this form. You know it. This is the formula for correlation coefficient, and the fact is that x and y receive the same treatment in calculating r. Okay? So if I reverse the variable that becomes x with that we called y and vice versa, that's not going to affect the r because they're being treated the same. So the answer here, whatever the r was before, it will still be the r. Okay, so the answer is A. Let us see. I don't want to do too many correlations. We spend a lot of time in correlation. Keep practicing. So, we didn't do a lot of the problems with design, did we? We should do a few of those, but no one asks me. Let's see. Yesterday we did normal. Okay, let's look at 27. Let me give you a moment to work on that. Oh, I left my microphone on. Okay, so let's see. 27. Y'all read it? Okay, so we want the factor levels. These are the factors. Factors are brand of racket and brand of tennis ball. And I want the factor levels is the question. What are the factor levels? The levels are Wilson and Prince for the brand of racket, and Dunlop and Penn for the brand of tennis ball. So the way I express that is C. Now, in the other options, A would be the brand of racket and the brand tennis. Those are the factors. Okay, that's not the factor level. Factor level is the different levels of the factor. So the factor for the physician health study, the factor levels were aspirin and placebo. And the other factor levels were for the placebo of beta carotene and beta carotene. That's how I would have said those are the factor levels. And that's what's happening here. And this is just to throw you off. B is just to throw you off. Location, we're not going to, they said the tennis players believe the effect of the treatments may differ depending on whether he is playing indoors or outdoors, so the experiment is conducted separately for 2 locations. That is not a factor in this. In fact, indoor or outdoor would serve as blocks. Now, you're not asked about blocks here, but the fact that I'm going to repeat the experiment completely in 2 different locations, those locations then are the blocks, okay? They're not the factor. I know this might be confusing, but I don't ask about the blocks. That was just to throw you off. But the best answer is C. This one is also to throw you off. And this is to throw you off. Okay, so that's that for that. Any questions about C? Let's see, 28. A psychologist administered a survey to a sample of her patients. Patients were asked if they regularly practice meditation, yoga, both, or neither. The psychologist assessed the overall mental health of each patient. The surveys and the mental health evaluations were given to a third party to analyze. The psychologist was not aware of whether the patient practiced meditation or yoga, and the patients were unaware of the purpose of the study. What is the answer here? Okay, so that was weird. Something came into my throat. Oh, okay. I kind of lost my voice all of a sudden. Okay, Okay, so the question when you want to know whether it's a study, observational study, or experiment, let's start there. You need to determine if there was any kind of treatment. Was there any treatment in this? What was the treatment? There was no treatment, right? There was just everybody received an assessment of mental health. Everyone got the same. There was a survey, and when the psychologist gave the treatment, they didn't know if the patient was doing meditation or yoga. There was nothing done. So all of these options were to throw you off. The answer is just, it's an observational study. Okay, this is not an experiment. So none of those are, it's not an experiment. There's no treatment. This is very straightforward. So always look, the first question is it an observational study or an experiment? And you'll know it's an experiment if there's some sort of thing done to people. And it's done to one group and not to another. Okay, in this case, everyone receives the same treatment, so this is not an experiment where you have varying treatments. So the answer is E. Okay. So we've been doing this for an hour. I'm going to leave it here. I'm going to ask you to finish this exam. Finally, tomorrow, I will answer any questions you have about this exam. If you don't have any questions about this exam, I'll be done with this one, and I'll be working on the last one on the list. That is for October 28th and November 2nd, that midterm. Okay? So prepare these two midterms, and we'll see you tomorrow. If you have any questions, I'll deal with those first. So send those to me either by email or in the chat, and I'll see you tomorrow. Bye.